What a great turnout today. It's really nice to be here. The presentations are super. I've got a ton of slides to go through. I'm going to fly through a bunch of these. Bob Plummer's out there, and he's waiting for my 40 minutes. So if you're all cool with 40 or 50 minutes on the slides, I'm good with that. All right. So evolution to revolution. 34-2 is the Ad-Hoc group currently working on next generation of DTV audio. The group was formed in August of 2013, meets roughly 2 times per month in a combination of teleconferences and face-to-face meetings. Looking at this a year down the road from where we were last year, it's incredible with the progress that we've made. And it was a dilemma there for a while for us, but we really sped things up. And a lot of that is due to the excellent contribution from the audio leadership group, which is made up of Yeshwant Muthusamy from Samsung, our vice chair, Skip Peasy from the NAB, Paul from CEA, our test coordinators. Skip will be our editor as well. Also, CEA and NAB have basically given us Skip and Paul's time and are covering their expenses for travel. So a round of applause for CEA and NAB, really, because we couldn't have things working as nicely as they are if it weren't for those guys stepping up, so it's just great. We have about 100 members on paper, which are made up of the groups, the companies, and many more of the ones you see there. And especially you'll find out what's key about Dolby Laboratories and the MPEG-H Alliance in a little bit. So moving on to the audio part, the future of TV sound is audio for ATSC 3.0, no question. And to describe it, Madeline did this before, but I just want to reemphasize this. When we hear the word immersive, we think of, at least I do, immersive surround sound, so being enveloped by the sound, but immersive in our case for ATSC 3.0 audio is a lot more than that. It really involves 2 pieces, the personalization aspect, of which I'll do a slide blow by blow so you can get a real grip on what we're offering. And then, of course, there is the enhanced surround sound that goes along with it. So to me, immersive means both those parts, so think of it that way. I won't go through all of these, but we do have 21 requirements that were handed down from S32, really important, became the basis of what we were going after. And we'll start with the personalization part of it. As I go through the requirements, I'll have some graphics and some illustrations, and you can do questions on them later if you like. So we'll have the ability to efficiently, and efficiently is really important for ATSC 3.0 audio, efficiently customize an audio experience with channels and objects. And I'm going to go through the definition of objects. We got a little bit of help from that, with that a little bit later down the road. I'll go through that. We can choose language. We can choose commentary. We can deal with impairments and do video description. We'll take care of the all-important loudness situation. And of course, we'll contour dynamic range to all the different devices that'll get used. So when we talk about personalized features, one of the things that comes up immediately is being able to understand the storyline and the dialogue. We don't get a lot of complaints about audio at NBC, but if we do get one that funnels through, it's usually because someone can't understand what's going on in the story, because some parts of the story are being overwhelmed by the music, or the announcers are being overwhelmed by the crowd in a sporting event. So ATSC 3.0 audio is going to do a slam dunk on this and fix it. We also found out that it can do it in a fairly simple way. One of the features is being offered up by one of our proponents that doesn't even impact the infrastructure of the television broadcast plant to be able to work this. Along with that, we'll be able to pick out languages, which doesn't sound like a big deal, but currently right now, if you think about it, in some cases we have the option to choose a Spanish language in ATSC 1, but in a lot of cases there are no extra languages. ATSC 3.0 makes this efficient and capable and easy to use. We hope this will be a big deal to our audiences. In addition, video descriptive service will be able to be added to a program, and we'll be able to choose the levels of the video descriptive service or the languages that they'll be able to be conveyed into the audience. Personalization my way. This is an interesting slide if you really take a look at it in depth. I'm watching a ball game, and I can choose where I want the commentary to come from, or no commentary at all, and I'm able to do that over the airwaves and also via broadband. So there'll be rights issues that go along with this, but this is a really interesting feature which really opens things up quite a bit and really shows off the capabilities of ATSC 3.0. Just one example that was offered up from one of our proponents, just to put it in as a really good effort on their part. So you have a situation here of the sensitivity with the COM Act and with loudness normalization. It's possible that we might be able to have a system where we can add a COM identifier inserted upstream through a transcoder, which labels the content as being COM compliant and can signal downstream encoding as to whether or not additional COM hardware needs to be employed. In the case of the upper diagram, it doesn't because things were certified upstream, and this would be similar to the way some television networks work now. Below that, you might have a situation where there was no loudness normalization applied upstream, and now the content is smart because there's no COM identifier, and the encoder can pick that up and understand that it needs to act on that and add loudness normalization at the back end in real time. Not as effective as doing it up front when you can do a loudness shift instead of real-time processing, but certainly would make things COM compliant. So I just wanted to show that as a kind of a generic example of the kind of things that ATSC 3.0 could do. Dynamic range control should not be new to anybody. DRC will be employed to take care of a couple of things. One is contour audio directly to the device, which is easy. The device knows what it is, and it can understand how much range it's capable of. Or if we work our way down to the devices that are more capable of wider dynamic range, we might want to engage a situation where we want to reduce dynamic range in a home theater because it's late at night or something like that. And in the middle, we have dynamic range controlled because a television set, a flat panel TV can only handle so much dynamic range, so that's also taken care of. But the idea here, of course, is always keep in mind that the content creator on the left-hand side here would like to give the best experience to the full audience, and they'd be able to produce that, and ATSC 3.0 audio would be able to customize that for both the audience member and the equipment that they're using. Future of TV sound efficiency, really important. Again, ATSC 3.0 audio does this really well. In the old days or the current days in ATSC 1, it's such a simple diagram but so effective. A complete main, which is what we'd use on NBC or Fox or CBS and ABC or whatever, in stereo or 5.1 is usually locked down to 384 kilobits per second right now. You could check it now with a meter. That's probably what you'd find in broadcast. To add an ancillary soundtrack, of which we're constrained to do one because of MVPD distribution downstream, you're usually talking about adding another 192 kilobits. And that soundtrack is usually mono, and it's not the best thing going. So you add both of them together, and you're talking about a good surround sound experience at 384, not the best ancillary soundtrack alternate language experience at 192, and you add it up, and you get 576 kilobits. When you move on to ATSC 3, it's totally different. I borrowed the slide from Dolby, who are one of our proponents in the project. So we work a music and effects complete main at 192, and now we can layer on other soundtracks on top of that to take care of English dialogue, in this case, Spanish dialogue, and then both of the VDS services. And now we're not creating additional soundtracks, we're layering and mixing them in. So it creates a lot more efficiency. And now we can do something like this, which is at 4 different programs. So we have 2 languages, and we have a VDS, and we have a full regular surround sound program. And we're doing it at 384 kilobits. So really efficient. Really is something that we've recognized as being important in the new system. Enhanced surround sound. So this is the other piece of it as we move away from personalization. So improved spatial resolution in the sound source localization. What this really means is, think about it this way. The easiest way to pick this up is you can have a 7.1 environment, which has been around for a while on Blu-ray and in the theater, and we're adding height to that. We're using a system over and over again as an example in our project, which is 7.1 plus 4. So it's the familiar 7.1 surround sound with 4 overhead speakers, all discrete, all able to get the audio to exactly where you want it pinpointed in that sound environment. So we're going to use channels and objects or elements and metadata similar to fader automation. I'll explain that in rendering and hope that I'm able to do that pretty simply so everybody can pick up what happens in the system and how it works at home. Metadata is an important piece of it, and the decoder has a renderer in it, which is really important because that renderer is the go-between between the content provider and the consumer to understand, I have content, what was the intent, and what are the limitations on where it can go based on the home system. Interesting slide here, but I want to start off with a really effective and simple definition of an object that was given to us by MPEG-H, one of our proponents. An audio object is basically a channel that can be positioned or panned during playback, so it's not locked down to any one place during creation. And hopefully that'll become clear as I go through this slide. So on the top part of this slide, we have the broadcast realm. On the bottom part, we have the consumer. So at the top, in current ATSC1, over in the top left, ATSC1 through plant distribution can do 16 channels of audio routed inside of HDSDI. And that was all standardized by SMPTE. When we moved to ATSC3, we hope for SMPTE standardization of distribution during production with the section I've shown there on the right. But also, we could be pushing around 40 elements and channels, and I picked that number. It's just one that I picked. It may not go to that many. It may become more than that. Really not sure just yet. But it was a good place to start. And keep in mind that we will be using HDSDI in the beginning, but also IP is going to play into this, so we're going to have IT distribution as well, as audio moves off of an HDSDI platform like it is now and goes to IP. So keep that in mind. So things really just kind of become wider and less restricted. If you look at home on the lower left side, with 5.1, when things are emitted, it's a source equals one channel of audio that equals a destination of one loudspeaker, basically, inside of 5.1, so we would have 6 of those, and the subwoofer being the 6th. So it's one channel equals one speaker. And it's very rigid, it's bound, it doesn't change. That's the way it is, that's the way it stays. We've made good use out of it, but now we're going to progress to something different. Now we have metadata and a renderer and many more loudspeakers in the home on the right-hand side. So we could have many channels and many objects, the objects being sound with metadata associated with them in terms of where they should be positioned in the home reproduction system. Goes through the renderer. The renderer understands through the metadata what the content provider wanted to do, but also understands the limitation on the consumer side based on the amount of speakers and also based on the reproduction device. And it acts as the go-between to best fit the content creative aspect into the home reproduction aspect. And it does that steered by metadata, and it also does it by understanding the room environment, and I'll get into that in a little bit. You good with this so far? Rendering, again, in the case of the top one, we're rendering to headphones, so we're going to have a really great experience there, which I'll get into in a minute. The set-top box, in this case, is taking in the content from the left-hand side, which is trying to basically fit it in for a great experience for everybody. And the set-top box in the middle that's working with the flat panel display understands how to contour that content and make it work inside of the 2 speakers that are available in the flat panel display. In the case of the AVR, or audio video receiver on the bottom, things are opened up a little bit more because we have more to work with. And the AVR is able to work, in this case, that diagram at 7.1 plus 4 with the 4 overheads and 7.1 surround sound happening as the base layer underneath of it. So the renderer becomes a really important part of this whole process. Rendering for headphones, headphone reproduction will simulate height and depth sounding more like speakers and the feeling of listening in a real room instead of sounding flat. So it's having immersive through your loudspeakers, which is really key because so much of ATSC3 audio could end up coming from mobile devices and tablets using headphones. Rendering for home theater. Again, being able to choose things the way you want them, having the AVR have a rendering device in the decoder inside of it to understand how to marry the intent of the content provider with the limitations of the home environment or the flexibility of the home environment. So it's kind of like the go-between. The metadata gives it an idea of what the content provider wanted to do, and the analysis in the room, in this case with the AVR, lets the renderer understand what it has to work with and get the best experience. So things can really be pinpointed to where the content provider wanted them to be among or positioned within the sound environment that's created by the loudspeakers and not necessarily locked down to any one specific loudspeaker. It becomes agile, and it becomes a really nice, lifelike experience, getting us to that next level above 5.1. One thing I also want to point out, which I didn't mention before, you'll notice on all these little graphics that I've made up, there's always a normal button. And the normal button is key because when you add these kind of features, folks who don't understand it completely can get into a little bit of trouble when they mess around with the knobs. So the normal button is there to be able to bring you back to baseline to make certain that you could have a rescue in case you get in trouble. And I think that that's something we really need to impress upon our consumer electronics folks to make certain these kinds of features are put into the devices that we end up creating here. I think it's really important, and I'm going to try to really push inside of S34-2 to make certain that CEA understands that and we get the word across on some of that. Another thing, so this is the factor of, how many speakers am I going to be able to get into my listening environment, because I don't really want to be cutting holes in the ceiling and all of that. So you can do that if you like, and actually I found out you can replace your hi-hats with speakers if you want, and you have them already, and it just happens that my room works out perfectly like that, but Susie won't care. Over here, the speaker on the right-hand side is an example of a top-firing driver that lets us create immersive by bouncing the immersive sound off the ceiling and not having to put speakers in the ceiling. So these kinds of devices are going to start to pop up. And when I heard about immersive sound years ago, I was skeptical because of this problem. But when this was shown to me and there were solutions to get around the issue of having to put holes in the ceiling and run wires and all that, it became more obvious that this could be a really great success. In addition to the speaker that you see on the right-hand side, there are also going to be the simplest immersive soundbars. So from one environment, or from one position, whether it's a soundbar located underneath the screen or wrapping the screen, we've seen that also from one of our proponents, we'd be able to do really good immersive sound without too much hassle in the living room. So getting off of the features and the gear, let's get to brass tacks on how we're doing in S34-2. So the call for proposal roadmaps the whole project. Kudos to the authors that put that together inside of 34-2, and of course to Skip for being a great help with that and putting the paper together, actually. Skip, great job. The CFP main sections, audio system requirements are built into that, right? Because everybody needs to know what we're trying to accomplish. We had proponent registration built in, a pre-certification process for proponents to make certain that we could understand that the proponent who wanted to be involved in our project really knew what they were doing and able to meet the requirements, both from a requirement standpoint and also a sound quality standpoint. Then we go into a section called Phase 1 listening tests, which contain formal feature evaluations, which are kind of yes, no on do you meet the requirement. And there will also be an opportunity for proponent demonstrations. Phase 2 is the decision-making process that is a little ways down the road yet. Test coordinators have their review that they will present to the entire group saying, here's what we collected, here's the data, here's what we found, here's how we think things have gone. There'll be an information analysis of the whole group at that point, going through everything that we've collected and having a chat about where things stand. And then, of course, there'll be a member group decision on the technology. Fingers crossed we'll be able to do that smoothly. The candidate standard will come up after that once we understand what we're trying to standardize, which one of the technologies or ones of the technologies have made it to that point. And then, of course, the proponents would help us with the candidate standard. And Skip, again, is going to take the lead on editing the paper for us, which is just terrific. So how am I doing time-wise here? I got to really go through this pretty quick. Oh, okay, so in terms of testing, 2 testing parts come up. 11.16.2 was used for pre-certification, and BS 1534 is going to be used for the comparative tests, which will happen from the point we're at right now forward. And then we're also using a 30-channel loudspeaker position table with our content. We've had 15 content owners provide 115 clips, 7 genres, 6 audio formats, pretty extensive, great contribution, all different kinds of content to make sure that we tax the system with the right bits that really are representative of the kinds of things that we listen to. The speaker configuration that you see on the right is, again, that familiar 7.1+4 that I keep using over and over again, which we like and think that is a good entry into immersive. And the diagram on the left shows how a compliant listening room speakers are mapped piece of content channel out to the loudspeakers. So that all became important when you went into testing. We selected content at a meeting at Qualcomm in San Diego, which worked really, really well. We spent 2 days there in a really efficient process to make certain that the content was what we wanted to use, whittle it down to the most important parts, make sure that the loudness was correct and that everything would work smoothly. And we got through 60 clips. In the 1116 method, the important thing that we were trying to do here is reveal what it took to get a score of 4 or better in terms of the bit rate of the content. And our proponents have worked through that and resulted in 2 proponents, Dolby Laboratories and the MPEG-H Audio Alliance, moving on to the next phase, which we call phase 1. So out of pre-certification and into phase 1 now. And it's Dolby and MPEG-H. MPEG-H made up of Fraunhofer, Qualcomm, and Technicolor. So phase 1, the methods we're using, content preparation has already been taken care of. It was really important that the streams that we got from our proponents that will be used in the formal testing are valid, robust, workable. And we needed to spend some time. We went up to McGill and made certain that those streams are in good shape, and they are. Thumbs up on those, so we're good to go for distribution. They were validated, and we brought in an additional expert to look over the process to make sure that they were good to go. So we're in good shape there. So the method in phase 1, which is the more rigorous one, is called BS1534. And what we're trying to do here is determine scores among the proponents to see how pieces of content and the codecs work out in terms of how the listeners rate them. And that will be happening across the next 6 weeks or so. Feature evaluation and test site visit will start week of June 1st and June 8th. So week of June 1 will be at Dolby in San Francisco. June 8 will be in Germany, first at Fraunhofer, then at Technicolor. Anyone can join us there. We're scheduled to go. The test coordinators will be there. I'll be there as well, as will Yeshwan, our vice chair. This gives the test coordinators an opportunity per the CFP to review testing in process and also do this kind of pass-fail on the features where you're able to come up with a solution to all the things that we felt were a requirement. It also permits the proponent to demonstrate features which may be in addition to and exceed those by the CFP. We call that going above and beyond. Show us your best. If there's something that we didn't ask for and you think it's going to be great, why don't we hear it and demonstrate it to us and see if it's an important feature for our members. So proponent demonstrations, if you can't go to San Francisco or can't go to Germany, or also if you haven't been keeping up in the ATSC 3.0 audio process, this is a great time to come to Georgia. We're responsible for getting into Atlanta, Georgia in the middle of the summer. It was us. You come to Georgia, and in one fell swoop, you'll be able to go in and have a meeting and a demonstration with our audio proponents during the face-to-face that occur there. So it's different than test and evaluation, but it gives exposure of the technology to our members in a simple way, hopefully because you were already going to be at the face-to-face, and now you'll be able to catch up on what's happening in audio pretty simply and at one place and one time. Open to all the members. Members can schedule private sessions addressing their concerns and needs, affording them an opportunity to ask any question outside of a meeting. So you can go in and say, here's my situation, how are you going to address it, and get an answer. Different material may come up. We've had some members say, can I bring something in? That's also a possibility, so we can tailor the material that will be demonstrated to the specific listener. Show and discuss features that exceed or go above and beyond, that again. And then this way, all of our members can really get great feedback in simply in just showing up and scheduling an appointment in Atlanta during the face-to-face. So, great progress here, terrific, unbelievable since last year this time. We've really moved down. We're about 2/3 of the way through. As you can see, right in the beginning of the summer part, we're just going into phase 1 tests. We're going to come up with the demo event, phase 2, the decision-making process, and then a recommendation, and then, of course, the candidate standards. So we started this in January, and on the books, we're going to hope to wrap it at some point at the end of the summer. So, ATSC 1.0 audio evolutionized television sound by introducing digital technology, quality-driven loudness control, yay, 5.1 discrete surround sound to the audience. 3.0 will revolutionize TV sound, expanding digital technology in an extremely efficient manner, bringing a host of new features to the user, enabling personalization and enhanced immersive surround sound with almost unlimited boundaries. So what's important to our members and the takeaway? This next section really talks about how we really have to marry broadcast, consumer, manufacturing all together. Successful TV audio experience is the result of a well-planned marriage of broadcast and consumer technology. In ATSC 1, we learned that clear understanding and design of user accessibility of features is key to creating a technology that meets the goals of the system designers. I think we can do it better in ATSC 3 than we did it in 1, although in 1 was a great effort. And then moving forward, my biggest takeaway is if you haven't been tracking what's going on in ATSC 3 audio, leverage the test and feature evaluation visit in Atlanta, go to the July demos, gather the critical information, and make certain you can make the best decision for your company's unique operations and their needs. So show up. So thanks. I'll take questions. I guess I nailed it. Madeline. It's like having the boss go up to the microphone, right?
No, thanks, Jim. This is great. And actually, yeah, I just wanted to talk a little bit about process, then ask a question. So I want to piggyback on Jim's last point. If you don't mind putting the previous slide up for a second. So where it says moving forward, and in particular the last little bit that says your company's unique operation and needs, what I want to highlight here is that we very specifically didn't design a testing process that was going to come out with a score at the end that says here's the lower right-hand cell and boom, you're done. And this was very important. This came down from ATSC leadership in terms of guidance. The idea is that Jim's group is going to provide you with a wealth of information and a wealth of opportunities to gather whatever information you want. Then each member will make his or her own individual decision based on whatever their company's unique operation and needs are. So what I'm encouraging everyone to do is take full advantage of all the information that Jim's group is going to be providing and the opportunities for you to look at the demos and everything like that. And please be prepared to think this through and to come up with your own position so that when decision time comes, hopefully you'll have all the information you need. And I also want to encourage people that if you're looking at the information that's coming to you and thinking to yourself, gee, there's a key piece of information that ATSC ought to be ferreting out that they're not, and I'm not going to be able to make a decision until I get that, tell us. Because when it comes to the time to make a selection, we don't want there to be any roadblocks for that. We're under a tight deadline, and we feel like we've got everything covered, but please keep that in mind as you work this through. Thank you.
And thank you, Madeline. And especially the demonstrations that are going to happen in July were with all of you in mind. Again, an easy way for you to be at the face-to-face and have a private demonstration of the technologies so that you can make up your own mind, ask the important questions, and then put that together with the data that's been collected and hopefully bring that back to your companies, talk about it, and make a decision on the way that you'd like to go. So, thank you very much.